Hi everyone, I'm Teacher Puzio Wong, and today I'll be introducing you to Terraform and demonstrating how you can install and use the Terraform AOS-CX Provider to configure and manage your CX switch. First, what is Terraform? Well, Terraform is an open-source cloud and infrastructure provisioning management tool built on the Golang programming language and owned by HashiCorp. It's vendor agnostic, which allows users to manage multiple different systems from different vendors through the single tool. It's deterministic and state-based, which means that Terraform's backend will ensure your end systems will be in the exact state defined in your Terraform files. This involves adding, removing, and updating attributes based on your system's current state compared to what is defined in your configuration. Finally, users will use HashiCorp Configuration Language, or HCL, which is a human-readable JSON-like language, to define their Terraform files. Today we're seeing our customers use Terraform heavily in the DevOps and data center spaces. They're adopting Terraform due to its benefits of being deterministic and vendor agnostic, which makes it easy for them to manage their entire infrastructure systems through the single tool. Another similar provisioning and configuration management tool that we've seen is Ansible by Red Hat, which some customers use both of these tools in conjunction, taking advantage of each of their strengths. Terraform CLI is free to install. Terraform Cloud and Enterprise offer additional capabilities for a price. With these options, you can install it either on-prem or in the cloud, and it's recommended to follow HashiCorp's documentation for the most recent and accurate Terraform installation instructions. Link to the guide is shown at the bottom of the slide, as well as provided in the description down below. So how does Terraform work? Well, Terraform requires two input sources. One will be user-defined, and the other will be auto-generated. First, the Terraform configuration file. This is a .tf extension file written in HCL where the user defines what state their infrastructure should be in. The Terraform configuration files use providers created by vendors to define resources that allow the tool to communicate and configure the infrastructure. Then you have the Terraform state file. Terraform automatically updates the state file during its planning and application steps. In some rare cases, users may want to manually manipulate this file, but it is not recommended. Now, I mentioned steps. What does that mean exactly? Well, once a user has written their configuration files, they will initialize Terraform and apply their configuration. The tool will first begin with its refresh step. This is where it will query the end device to find the user's configuration file and get its current state. Then, Terraform will create an execution plan based on the difference between what is discovered in the end device and what was defined in the configuration file. Once the user confirms they want the changes applied, Terraform will enter the application step and begin provisioning your infrastructure and updating the state file. Integration of the AOS-CX switch platform and Terraform comes in the form of the AOS-CX Terraform Provider. Providers are written by vendors to provide all the code and operations necessary to configure and manage your infrastructure. The CX Terraform Provider provides a set of configuration management modules and resources specifically designed to manage and configure AOS-CX switches using REST API. Requirements include REST API to be enabled on the switch and firmware 10.9 or greater. The CX Provider follows the required behavior for all Terraform providers in enforcing a declarative approach. The AOS-CX Provider initially logs into the switch and creates a cookie-based session that's used for the entire execution. Then, through a series of REST API calls, the provider will ensure the switch is in the defined state. Here's what a typical execution will look like. First, we log into the switch using the credentials found in the Terraform configuration file. Then we retrieve the current state of the switch using the get method. We compare what was found with what is defined in the configuration file, and if modifications are necessary, the following could occur. A post method is executed to create a resource, a patch or put method is executed to update a resource, and a delete method is executed to remove a resource. In Terraform version 0.13, they added support for automatically downloading providers from the Terraform Registry. The Terraform Registry is a resource for distributing content to use with Terraform, such as providers, modules, and resources. Users can simply define the AOS-CX Provider as one of the required providers in their Terraform configuration file, and Terraform will install the provider upon executing Terraform init. As we continue to develop more features and improve functionality, the current version of the provider is considered a pre-release. Therefore, users will have to specify the exact version of the provider they'll want to use. Once an official release is published, users can include operators in the version constraint. Here is an example required providers block that can be found in your Terraform configuration file. For installing the AOS-CX provider, simply define AOS-CX followed by the version and the source, which is the Aruba namespace followed by the provider name AOS-CX. Remember, the version for pre-releases must be explicitly defined. To find the latest supported version of the provider, check out the provider on the Terraform Registry or on the AOS-CX Terraform Provider GitHub. Links to these are in the description down below. To ensure the required providers block is defined properly, once you've saved your configuration file, execute the Terraform init command, and you should see an output of Terraform initializing the backend and installing any providers defined in that block. An example output is shown here. With your required providers block defined and your AOS-CX provider successfully installed, it's time to define your CX switch attributes and resources. The first section to define will be the provider block, and this is where you'll define your switch and its connection attributes. Here you'll define the host name, followed by the login username and password. This user will need read-write access to the REST API. For protecting sensitive input variables, it's recommended to follow Terraform's guidance. A link to their guide is shown on the slide as well as provided in the description down below. Now that we've defined our switch, it's time to define the resources we want Terraform to configure and manage. Each resource correlates to a CX-specific feature on the switch, such as interfaces or VLANs. Remember, Terraform's behavior is deterministic, which means its execution is predictable and will ensure the end device will be in the exact state defined in the configuration file. To see all supported resources and the required and optional values, see the AOS-CX provider's documentation on the Terraform registry. Here is an example of defined AOS-CX resources within a Terraform configuration file. To begin defining a resource, use the keyword resource followed by the resource type and assign it a local name. Then within that resource block, you'll define all the required and optional values using two-space indentation for each nesting level. A link to the HashiCorp style convention guide is provided within the slide as well as in the description down below. Now that you've defined your configuration file, it's time to apply those changes using Terraform. Terraform runs in the context of a working directory, which contains your configuration and state files, also known as a root module. Typically, your configuration file will be named main.tf, and once that's defined, you execute your Terraform init command to initialize your workspace, and then Terraform apply to initiate the plan and apply stages. Terraform will report the changes and differences it's found between your device and the Terraform state file. After receiving a confirmation from the user, it will then execute the necessary REST API calls to get the AOS-CX switch into the desired state. Now that we've gone through the basics of Terraform and getting started with the AOS-CX provider, let's go ahead and walk through an example. Here I'm in my sandbox working directory, or my root module. In this system, I'm using Ubuntu 20.04 and Terraform version 1.2.4. First, I'll need to create my Terraform configuration file. I'll create a main.tf file and begin by defining my required providers block, beginning with the provider name AOS-CX and specifying the specific pre-release version. Now I'll define my AOS-CX connection attributes by using the provider block followed by the provider name AOS-CX and the required connection variables hostname, username, and password. Next, I'll define my resources. In this example, I'll simply define a couple VLANs and some interfaces. As a reminder, the documentation section on Terraform Registry is the best place to find which resources the CX provider supports and their corresponding optional and required values. Now I'll go ahead and save this file. And since this is a brand new workspace, I'll need to execute Terraform init. If I don't, then I'll receive an error when executing Terraform apply, prompting me to execute Terraform init. Now that that's done successfully, I can execute Terraform Apply. But before executing Terraform Apply, let's go ahead and take a look at my CX switch. As you can see, I just have the default VLAN here, and if I check out my interfaces, they're in a default state as well. Let's see if we can change that. So I'm going to go ahead and return back to my Ubuntu machine and execute Terraform Apply. Once I've done that, you can see that I'm shown all the changes Terraform is suggesting to make. And I'm being prompted to accept the changes. If I enter in yes and approve the changes, I can see that Terraform has added these resources. Let's go ahead and take a look at the CX switch. And we can see the VLANs have been created and the interfaces have been configured. Now let's see how Terraform's deterministic behavior works. Let's say I remove VLAN 20 from the switch. You can see it's removed from my VLANs as well as the interfaces. Let's go ahead and return back to my Ubuntu machine, and I'll perform that Terraform Apply again. So here I can see that the resource was not found on the switch, and that Terraform will perform some actions to correct the end device's state. Let's go ahead and check the switch out again. If I do the show run, you can see that VLAN is added back to my interfaces and is showing back up in my configuration. As I mentioned previously, storing switch credentials in plain text may not be ideal for security reasons. It is recommended to follow HashiCorp's guidance on protecting sensitive variables, as I mentioned earlier in this video. Here I'm going to show you one method of using environment variables to store your credentials. Using the variable block in my configuration file, I'm going to be defining two variables, CX username and CX password, defining them as strings and flagging their sensitivity to true. Now I'll change the values of username and password in my provider block to be the var.variablename. Once I save the configuration file, I'll simply want to define the variables using the syntax capital TF var and then the variable name. I'll also go ahead and remove a VLAN from my configuration file to show the behavior of what it looks like when Terraform wants to remove or destroy a resource from that end device. Now I'll go ahead and execute Terraform Apply. And I can see that Terraform will be removing that resource. So I go ahead and approve. Let's take a look at the switch. I can see that the VLAN has been removed from the configuration as well as from those interfaces, all using those new environment variables that we set securely. For all the latest information and detailed guides on getting started with AOS-CX in Terraform, be sure to check out our Aruba DevHub. To view the latest documentation and find the most recent provider versions, visit our AOS-CX provider page on Terraform Registry. Links to these resources can be found in the description down below. That about concludes today's video. Be sure to look out for more videos from Aruba's automation team, where we'll showcase more workflows utilizing the power of AOS-CX and Terraform, as well as many other automation tools and frameworks. Thanks for watching, and happy automating!